In this video, we're going to look at questions related to finding the point of intersection of a line and a plane, two lines and two planes. Okay, two planes we call it a line or intersection rather than a point or intersection. Alright, so let's start off with two lines intersecting. Okay, so first thing we take note is that if you have two curves and they intersect at endpoints, then what it means is that if I try to solve the simultaneous equation of the two curves, I should have n solution. Okay, so this is how we can use to check whether two lines intersect. So if two lines intersect, then I can say that if I try to solve the simultaneous equation of the two lines, I should have some solution. Okay, normally it will be one because two lines, if you intersect, there will only be one point of intersection. Okay, so the opposite is true. If there's no solution, then there's no intersection as well. Okay, so this is how I can check for intersection. Okay, so let's look at this example. We have two lines here and we want to check whether they intersect. Okay, so the idea will be to make use of simultaneous equation. The blue one represents line 1, the red one represents line 2. To solve this simultaneous equation, we can focus on writing each of the line as a parametric form like this. I prefer this way because this simply tells you that the x must be equals to x because the point of intersection lies on both lines, right? So the x coordinate must be the same, so I can equate this together. Same for the y and z. Okay, that being said, okay, we can form three equations like this. Okay, but you take note that although there's three equations, but there are only two unknowns. Okay, so how do we solve the two unknown? Okay, typically we only need two equations. So what I can do is to focus on the first two equations right here. And then I go on and solve the simple simultaneous here first. Okay, solving this, I will get lambda and mu like this. Okay, 19 over 10 and 3 over 10. Okay, but then this is not the end though, because our job is to make sure that it satisfies all the three equations, not just the first two, right? Because I only make use of the first two now. So I need to check, okay, if this set of mu and lambda satisfy equation 3, this one. Okay, so go on and substitute the values inside. Okay, so from the left hand side, you check that it is equal to 5.8. For the right hand side, you check that it's actually equals to negative 1.4. So obviously they are not equal. So what we can conclude is that it cannot satisfy all three equations. Therefore, the two lines do not intersect. Okay, there's no solution that satisfies all three equations. Okay, so in the same way, I can say that, let's say, if the lambda and mu that you found from equation 1 and 2 manage to solve equation 3, okay, then I can say that, okay, we got a solution. Okay, the solution will be the point of intersection, therefore the two lines will intersect. Okay, but we haven't really find the point. So how to find a point? Okay, we just need to substitute the value of lambda back to equation 1. Okay, or line 1. Okay, or in the same way, you can sub mu into line 2 also. That works also. Alright, so let's look at an example. So this was the equation just now, just that I changed the number here. Initially was -2, I changed it to 5.2 now. So the method follows. Okay, I make use of equation 1 and 2 to solve for lambda and mu. Okay, the value will be the same. And then I check whether they satisfy equation 3. Okay, so when I substitute inside, okay, the left and right hand side, I can see that they are both equals to 5.8. Alright, so what this means is that I can conclude the two lines will intersect. Okay, and to find the point of intersection, I can just substitute lambda equals to 19 over 10 into line 1. Okay, so the equation of line 1 looks like this, and this was the value of lambda that I substitute in. So I go on and evaluate. This will be the point of intersection. Alright, so this is how we can find the point of intersection. So for a line and a plane now, so first thing we check is whether they are parallel. Okay, So we look at a generic form. Let's say your line has this equation, your plane has the scalar product form like this. So if the line is not parallel to the plane, then it will definitely intersect the plane at some point. Because think about it this way, like if they're not parallel, then if you travel in a certain direction of that line, you will definitely get closer and closer to the plane because you are not parallel to the plane, right? So in that sense, you will touch the plane at some point, okay? So this is a illustration. Okay, let's say you have a line not parallel to the plane. At some point, you're going to intersect the plane, okay? So to check whether the line is parallel to the plane, okay, what I can do is to take the direction vector of the line, okay, and dot with the normal vector, okay? Because if I dot with the normal vector, okay, let's say it is equals to 0. Equals to 0 tells me that V and N, they are perpendicular. Remember, this is the property of dot product, right? So if the direction vector of the line is perpendicular to the normal, okay, that means it will be parallel to the plane, right? Because normal vector is this. If your V is perpendicular to N, that means it will be parallel to the plane. You see that? Okay, so that's how we can conclude. Okay, so in the same way, if it's not equals to 0, so it's not perpendicular, therefore the line will not be parallel to the plane. Okay, and hence it will intersect. Okay, so far we only check how to determine whether it's parallel. Okay, so even if it's parallel, there's two scenarios. Okay, scenario 1 is that the line is not touching the plane. If it's not touching the plane, then it will look something like this. Okay, the plane is here, it is parallel but not touching. So how can we check? It's simply to substitute a point on the line, okay, into the equation of a plane to see whether it satisfies the equation of the plane. So in this case, I'm going to sub r equals to a. Okay, a will just be a point on the line. I will substitute r equals to a into the equation of a plane, and I will check whether, okay, a dot n will be equals to t. Okay, in this scenario, it will not be equal because it's not touching the plane. Alright, so that's for scenario 1. Scenario 2, okay, when the line is touching the plane, okay, or I should say that the whole line is actually inside the plane. In that case, I just need, again, I will take any point on the line. I substitute the equation of the plane. It should satisfy. Okay, again, I'm going to use point A dot n will be equals to d. Alright, okay, my fault. D here is a constant, it's a number. It shouldn't be a vector. Okay, it's not both on. Okay, but you get the idea lah. Just check whether it's in the plane. Okay, so if you dot v and n is not equal to 0, we conclude that it's not parallel, right? So if it's not parallel, we try to solve for the point of intersection. So how do we solve for the point of intersection? Again, it is to use simultaneous equation. Alright, so the simultaneous equation 1 will be the line, 2 will be the plane. How do we solve it? Okay, we have done this earlier in the previous video. Okay, to find the intersection, I can substitute equation 1 into 2 like this. My job is to find lambda, right? So I will go on and expand the bracket. It will look like this. Okay, I will make lambda the subject. It will look like this. Okay, so this value of lambda will tell me the point of intersection. All I need to do is to take this value, substitute back into equation 1 and evaluate. Okay, that gives me the point of intersection. Alright. Okay, look at an example. Okay, you have a line and a plane. Okay, let's recap. You want to find the point of intersection. Okay, so here it's easy to check that it is not parallel. Okay, you can go on and take the direction vector and dot this thing. It will not be equal to 0. Okay, so I go on and substitute the equation of the line into the plane. Okay, again, recap. This is the line. Substitute into the plane. It looks like this. Okay, and I expand the bracket. Okay, like this, and evaluate the dot product. I get this thing. I solve for lambda. So lambda equals to minus 3. So all I need to do now is to substitute lambda equals to minus 3 back into the equation of the line. Alright, and then I get this point. So this is the point of intersection. Okay, so this is how you can find the intersection of a line and a plane. Okay, for two planes, okay, first thing we check is also whether the two planes are parallel. Okay, if the two planes are parallel, then we can split into two scenarios again later. We'll see later. Okay, for now just take note. If two planes are parallel, then their normal vectors are also parallel. Okay. Yep, so the scenario will go like this. If two planes are parallel, first scenario, maybe they don't touch each other at all. They're just parallel, but they don't touch each other. Okay, so how do we check whether they touch or not? All you need to do is to substitute any point in plane 1 into plane 2, just like the line example just now. Okay, so most likely, or confirm lah, if you do this checking, it will not satisfy equation of plane 2 because they don't intersect under this scenario. Alright, so scenario 2, if they are parallel and they intersect, then they are actually the same plane. Okay, they are together. Okay, so if you take any point in plane 1 and substitute into plane 2, you will find that it will satisfy plane 2. Any point that you use will satisfy. Okay, then we know that the two planes are actually the same. Alright. Okay, and if two planes are not parallel, then they will intersect at a line. Okay, look at this example. Okay, if two planes are not parallel, okay, we know for sure at some point they will intersect at a line. So the line here is the red line here. So consider this example. The two plane, the formulas are like that. Okay, to find the line of intersection, we have two methods. Method 1 is that you go on and solve a simultaneous equation, right? Like before, when you want to find intersection, you solve a simultaneous. But then now you only have two equation, 3 unknown. Okay, we can't really solve for x, y, z, but it actually makes sense because you are not finding one point here. Okay, so it makes sense that you cannot solve for x, y, z. Okay, so what we need to do is to treat z as a constant. Okay, to be precise, z becomes the independent variable. So z can take any value we like. But for now, we're just going to treat it as a constant. Okay, then I rewrite my equation like this. I throw all the z to the right hand side. Z to the right hand side. I will have this. Okay, two equation. And then I will go on and solve for x and y in terms of z. Okay, this should be fine, right? Yeah. Okay. So for example, in this example, I can take equation 1. Okay, I times 2. Okay, so that I balance the coefficient of x, right? And then minus equation 2. So the x term will cancel. So if I times 2 here will be 4. 4 minus 3 will be 1y. Times 2, this is 8. 8 minus 4 is 4. Times 2 is minus 6. Minus 6 minus 1 will be minus 5. Alright. Okay, so this is y. I found y. And to find z, I just substitute back into one of the equation. So in this case, I substitute back into equation 1. I will get x equals to this. Alright. So in a way, I managed to find x and y in terms of z. I can write them in terms of a column vector now. Like this. X, y, z. X is equal to this, y equals to this, and of course z equals to z. Alright. All I need to do now is to treat z as a independent variable. Okay, independent meaning he can take on any value. Okay. In that case, I can rewrite my column vector like this. Okay. The green vector will be kind of the constant, right, without z. The blue vector is those with z. Okay, I factorize out the z, so it looks like this. Do you see that? 7z minus 5z and z. Okay. So, and if you recall, this is actually the equation of a line now. The green one is the position vector of a point on the line. The blue one is the direction vector. And together they are equation of a line. Okay, in this case, it will be the line of intersection. Okay, so this is how you can find the line of intersection of two planes. Alright, so this is for method 1. Method 2, okay, it is to make use of the fact that the line of intersection will be perpendicular to the normal vector of the two planes. Okay, both the normal vector will be perpendicular to the red line. Hopefully from this diagram you can see the 90 degree here. Okay, so what I can do to find the direction vector of the line is to take the normal vector of the two planes and cross them together. Okay, reason because if you recall, when I cross two vectors, the output will be a new vector that is perpendicular to both of the two vectors. Okay, n1, n2. Okay, so in my diagram, n1, n2, let's say is the green and blue vector. Okay, if I cross them, I will find a third vector perpendicular to both of them. In that case, it will be the direction of the line, right? So this is how I can find the direction of the line. All right. Once you have the direction, okay, because equation of a line, I still need a point on the line, right? So how to find the point, okay, we have to make use of the equation of the two plane again, okay, like this. Okay, I will want to solve the simultaneous equation, but again, 3 unknown, 2 equation, it's not easy to solve, okay, but since we are just interested in finding one point, right? So we are allowed to choose one of them as the independent variable. Okay, because 2 equation by right, you can have 2 unknown and then you can solve for their value. So one of them can be chosen as the independent variable. Okay, so in this case, I'm going to choose z as the independent variable and I will randomly choose the value. Okay, I'll just make it 0 for simplicity. Okay, when I make it 0, my equation becomes like this. Alright, and then go on and solve my x and y. I get these values. Okay, and I can conclude that -4, 4, and 0, they are this is a point on the line. Okay, because I solved the simultaneous equation of the two plane, right, to get this. Okay, so this is a point on the line, and all I need to do is to put everything back into the equation of a line like this. Okay, this is the point on the line, this is the direction vector. Okay, so that's how we can find equation of a line of intersection between two planes, okay, using the idea of a cross product to find the direction vector. Okay, alright, so that comes to the end of this video. So make sure now you know how to find the point or intersection of two lines, a line and a plane, okay, and how to find the line or intersection of two planes. Okay, and of course this comes to the end of the video for the vector chapter. Okay, so make sure now you can explain all the points over here. Okay, so see you in the next video.